In this lesson, we're going to be looking at ratios and proportions. So we're going to have a few definitions to start with. And the first one is ratio. And you've probably heard of a ratio before. A ratio is a comparison of two numbers by division. And most of the time, we like to put that as a fraction because we can work with fractions pretty well, and we're pretty familiar with fractions. So a ratio is a comparison of two numbers by division. A rate is a ratio comparing numbers of different units or with different units. And so an example of a rate, and you all know this, like miles per hour is a rate. It's comparing different units. There's feet per second. There's words per minute if you're talking about typing. There's all kinds of different rates that we can talk about. The next thing is a unit rate. And a unit rate, as you see there, is a rate in which the denominator is 1. Now things aren't always in the form of unit rates, but you can change them to unit rates by dividing. So instead of having maybe you might say you go 120 miles in 2 hours. Well, that's not a unit rate because that's per 2 hours, or every 2 hours. You would want to change that to per hour, and that would be a unit rate if your denominator is a 1. Ratios should always be reduced to lowest terms, just like we do with fractions. Here you see 3 different ways to write proportions, or to write ratios. We have 3/4. We have it written as a fraction there. You can also use a colon, 3:4. And we read that 3:4, and then you can write it in words, 3:4. When you see rates, oftentimes they'll actually have their units right along with it, so you know what's going on there, what it's talking about. So here's a few examples. It says a school of 312 children has 168 girls and 20 teachers. And so you're looking for different ratios there. So we want girls to students. So girls, there's 168 girls over total students. So it has 312 children. And so there's our ratio, but we can reduce that. So we can think about reducing. Looks like 4 goes into both of those. So 4 goes into the top 42 times. 4 goes into the bottom part here. $78 times. We can even do some more reducing. 6 goes into this 7 times, and 6 goes into this 13 times, so we get a ratio of 7/13. And so that would be the ratio of girls to students. The next one, we want boys to students. Well, we don't have how many boys there are, but we know there's 312 students altogether, and there's 168 girls, which means the rest over are boys, so we can subtract to find the number of boys. And when we subtract here, we get that there's 144 boys, and so now we can compare that to the total number of students. So 144 over 312. And we can reduce that. Again, 4 goes into that 36 times. 4 goes into this. We did this one earlier. 4 goes into that 78 times. These can reduce by 6 again. So 6 goes into this 6 times, and 6 goes into this 13 times. So the ratio is 6 boys to 13 students. Sorry, that's a little bit messy there. So we have 6 boys to 13 students. We could then compare girls to boys. We're going to go ahead and skip that one. It would be similar. You could, well, we can write it here. So actually, what's nice about this, there's 7 girls to 13 total students. And then in the next example, it was 6 to 13. So the ratio of girls to boys is actually going to be 7 to 6, because we can only do that because these have the same denominator. And the last one, it says we want a unit rate, and we want students per teacher. And so we can write our unit rate down. We know there's a 312 students per teacher, per 20 teachers. And so to find a unit rate, which you'll have to do this later, is you're gonna divide. So we're gonna do 20 into 312. So that's once. This is 5. And so we multiply, we get 100. So we get 15 and 12/20ths, which that reduces to, if we want to put it in tenths, that would be 6/10. So 15.6 or 6/10 students per teacher. And so again, when you find a unit rate, go ahead and write the ratio and then do the division. So you have 15.6 students per teacher. That means for every teacher, there's 15.6 students. Moving on to the next part is unit multipliers. Unit multipliers allow us to convert a rate into an equivalent rate. And we see this when we deal with speeds. Here in the US, we work with miles per hour, but in other parts of the world, it's kilometers per hour. Physicists and other scientists like to use meters per second sometimes, so we want to be able to convert. So you should know your different conversion things. So a unit multiplier is a rate with different expressions representing the same quantity in the numerator and denominator. So different expressions, so you're going to have different numbers written, but they represent the same quantity. For example, 12 inches and 1 foot, those are different expressions that represent the same quantity. And we see a couple more down here. And before we get there, we see that if you multiply a rate by a unit multiplier, it won't change the ratio since it is equivalent to multiplication by 1. So let's look at these examples here of some unit multipliers. 1 mile and 5,280 feet mean the same thing. So when you divide the same thing by itself, this is really equal to 1. And so that's what this is saying. When you multiply by one of these unit multipliers, you're not changing the value because you're just multiplying by 1. That goes back to the identity property of multiplication. If you multiply something by 1, it doesn't change the value. Here's one you need to know. This says 2.54 centimeters is in 1 inch. And so let's go ahead and do a couple of these. There will be other ones that you need to know. So, for example, in this first one, it says use the unit multipliers to convert to the desired unit. So we have 28 feet to yards. So what we do is we take 28 feet. You can write it as a fraction because that might help some of you. I know you like to have it over 1, so 20 feet over 1, and we want to convert that to yards. So we're going to multiply that by a unit multiplier. And what we want is we don't want feet anymore, so we need feet in the denominator because then feet in the numerator will end up canceling with feet in the denominator. And if we can, we want to compare feet to yards. So how many feet are in a yard? Or what's the comparison? Well, there's 1 yard for every 3 feet. This right here is a unit multiplier. It's just really equal to 1. And now we can figure this out. The feet will cancel or reduce, simplify. Now we can multiply across. This is 28 yards over 3. And we can divide 28 by 3, and we get that that is 9 and 1/3 yards. The next one's 62 inches to centimeters. So if you didn't know, here's the conversions for inches and centimeters. So here we have 62 inches. we want to change that to centimeters. So we can put that over 1 and we're going to multiply. In this case, it's going to be 2.54 centimeters over 1 inch. And I'm using this form of it because I want the inches to cancel. And so the inches cancel there, and then you want to multiply this. We have 2.54 times 62. And so this is 217.48 centimeters. So 62 inches is the same as 217 and 48 hundredths centimeters. This last one here has a little bit more to it, because this is actually a rate. So we have miles per hour, so we have both miles and hours, and we want to convert that to feet per second. I'm going to go ahead and erase some stuff here just so we have room to work, because I don't want to run out of room. And we don't have a direct, so we have 17,000 miles per hour. And we want to change that to feet per second. So what we're going to do first is I'm going to go ahead and work with the miles. I want to change miles to feet. I don't know how many, oh no, I can do that. I do know how many feet are in a mile. So I want to make sure I change this to feet. And so we're thinking, I want to cancel the miles, so there are 5,280 feet in 1 mile. Notice the miles is in the numerator here and it's in the denominator here. That's how we want to set that up. So those will cancel and we just be left with feet, which is what we want. But we also want seconds, and right now we have hours. So most people don't know how many seconds are in an hour. Maybe some of you do. But what we can do is we can convert to minutes first. So I want to get rid of hours. So hours, since hours is in the denominator here, I want it in the numerator of my fraction. So there's 1 hour for 60 minutes. But again, I don't want minutes. I want all the way down to seconds. So now this hour will cancel with this hour, but now I have minutes, so we're going to think, okay, I want to cancel that minutes, and so there are 60 seconds in 1 minute. These minutes will cancel. And when we figured this out, and you guys can multiply it on your own, I'm not going to multiply it here, partly because I'm out of room, and I know you can handle this on your own. In the numerator, when we multiply across, we have 17,000 times 5,280 times 1 times 1. So we have 17,000 times 5,280. And what's our units in the numerator? Well, it's feet here, so feet. And in the denominator, we have 1, 1, and 60 times 60. And I'm going to go ahead and put my ratio of units over to the right, and what was left in the numerator was the seconds. So you can multiply the numerator, multiply the denominator, and then do that division to find out how many feet per second that would be. So that's unit multipliers and converting different forms. Very important to be able to know how to do that. In science, a lot of times they use the metric system, whereas we use our standard system, and so it's helpful to be able to change those things. Next thing we're going to look at is a proportion. I know this type is a little small here, but we have A over B equals B over C, and that's a proportion. A proportion is a statement of equality between two ratios. So a proportion is when you set two ratios equal to each other. Now within this proportion, I'm going to in fact rewrite it. A over B equals C over D. We have some terms here. A and D, the first number listed and the last number are first number and the last number are called the extremes. The ones in the middle here are called the means. So B and C are called the means. And so there's a property here, the cross product property says the product of the extremes equals the product of the means. It's called the cross product property because really when you have A over B equals C over D, you can say the cross product A times D equals B times C. So you make an X there in the middle, A times D equals B times C. And that property can be used to solve proportions if you have 3 of the 4 parts. So if you, like looking at a proportion, if you have 3 of these things are numbers and the one's a variable, then you can solve that. Just real quickly, the reason the cross product property works is really because of the multiplication property of equality. We could multiply both sides by the same thing to cancel some of the things there, and that would give you this equation right here. So an example 4, it says solve the proportion 7/8 equals x over 4. And what we just learned, we can use this cross product property. We have 7 times 4 is 28 equals 8x. And that should be a nice simple equation to solve. We can divide both sides by 8. We can do some reducing here. 4 goes into this 7 times, and 4 goes into this twice. So we have 7/2 or 3.5. Either way is fine. And so we can solve. And the way that we solved was to cross multiply. This next one looks a little more confusing, and actually we solved things like this in the last chapter because we would think, oh, there's fractions, so let's go ahead and multiply by the least common denominator. You can do that, but since this one actually turns out to be a proportion, which again is a fraction equal to one other fraction, we can use the cross product property again. And what we'll do is we can do the cross product. Now be careful with this. This is 7 times x plus 9. So make sure you put it in parentheses because it's multiplied times that whole thing. And over here, this is 5 times x plus 15. And then, again, this is an equation we learned to solve earlier. We can distribute. We have 7x plus 63 equals, and then distributing over here, 5x plus 45. And now we want to solve. We can get the x's to one side, so we'll subtract 5x from both sides. And that gives us 2x plus 63 equals 45. And then we would subtract 63 from both sides. That leaves us with a 2x on the left side equals, and then subtracting there here, that's a negative 18. And then we can divide both sides by 2, getting to the answer, which is x is equal to negative 9. I'm sorry here, I made a mistake. I wonder if any of you caught this. 5 times 15 is not 45. That's what 3 times 15 is. So I have to go ahead and make some corrections here. So that 45 is really a 75, which means this 45 here is a 75. And then 75 minus 63 is 8. And that will change our answer also. So this 75 minus 63, sorry, is 12. And 12 divided by 2 is 6. So x is equal to 6. And we could plug that back into our original to check if that's correct. We can use proportions to help us solve other problems. So in these examples, we're going to be able to set up a proportion. and then solve that proportion. So here a car travels 250 miles on 9 gallons of gas. Well, that's a ratio. So we have 250 gallons miles, and they use 9 gallons. That's a ratio. Well, if we can set that equal to another ratio, we'll have a proportion that we can solve. Here it says how many gallons are needed to travel 360 miles. So we want the same ratio, so we had miles on top for our first one, so we want miles on top here, and we're trying to figure out how many gallons. And we learned that we could solve proportions by cross multiplying, so this would be 250x equals 360 times 9, and dividing both sides by 250, we can figure out what x is. So figuring that out, 10 reduces with these. 9 times 36 is 144. 36 times 9 is 324. In the denominator we have 25, and then we can divide that. 25 that goes once. 74 times 74, and then that goes in twice, which is 50, 24, so we get 24 25ths, or 0.96. So x is equal to 12.96, and that would be gallons. The next question: a car dealer typically sells new and used cars in a ratio of 3 new cars to 2 used cars. So right there we have a ratio. We have ratio of 3 new cars, 3 new to 2 used. If he wants to sell a total of 325, so this is a total of 325, what goal should he set for the used car sales manager? So this is the guy dealing with used cars. Well, if we have 3 new to 2 used, that helps us figure out another ratio, because we want to deal with total, and so we want to deal with used cars to total. Well, in our ratio here, we have 3 new to 2 used, which means that would be 2 used to how many total? Well, for our ratio, that would be 5 total. So for every 5 that are sold total, 2 of them are used, and we get that from the 2 plus 3 is 5. And then we can set this equal to, we want to find the number of used cars needs to be sold if the total altogether is 325. And so now, once again, we can cross multiply. We get 5x equals 2 times 325. 2 times 325 is 650. And then we could divide both sides by 5, and that gets us 130. And so, to answer the question, you need 130 used cars to be sold.